Hi guys, welcome back to BioBulletin. This week we're going to be discussing a few of the ways in which nanotechnology could assist the fight against cancer and aid treatment and diagnosis. For those of you who are new to the channel, I'm Kanishka.
And I'm Viven, and we just want to say thank you for all the support that we had from our first podcast last week. It's really encouraging. We hope to deliver you with the best biological content every week.
So, a brief intro into what nanotechnology actually is. It's essentially a really exciting prospect which combines microscopic, hence the word nanotechnology, to aid us in delivering and diagnosing um, cancers and a variety of other diseases, and also assists us in the process of drug delivery. Um, so it's kind of changing the entire landscape of medicine by helping us treat what was previously thought of as extremely fatal or potentially even incurable diseases.
So, a little fact file about cancer. So, cancer is the uncontrolled growth of abnormal cells in the body. It develops when the body's normal control mechanisms stop working. So, old cells don't die, but instead they grow out of control, forming new abnormal cells. There are exocells that may form a mass of tissue called a tumor. So, quick stats, there are around 367,000 new cancer cases in the UK every year. In females in the UK, there were more than 179,000 new cases in 2017, and in males, the same year, around 187,000. Every 2 minutes, someone in the UK is diagnosed with cancer by these stats. Incidence rates for all cancers combined are projected to rise by 2% in the UK between 2014 and 2035. That's around 740 cases per 100,000 people by 2035.
So obviously, as Vivian just mentioned, cancer is a huge issue. And one of the biggest things to take into consideration when treating cancer is early detection. So by detecting cancer early before it spreads to levels 2, 3, or 4, you can really help it really helps doctors to get ahead of the cancer and treat it at the origin site. Typically in cancers, a tissue biopsy would be required to make a diagnosis. And a tissue biopsy is one in which a syringe is inserted into a tumor and fluid cells are drawn out, which are then analyzed to test for the presence of specific biomarkers which indicate
Kanishka,
cancer cells. Yeah.
with tissue biopsies, didn't they? Wasn't that an old method? Why is it coming back into the news now?
Well, see, tissue biopsies are still the most used method, but work on liquid biopsies are being done in which the blood is tested for certain cancer indicating cells, and that uses a nanotube. So I'm not sure if you've found this in your research, but researchers at the Worcester Polytechnic Institute have developed a carbon-based nanotube CTC chip, which essentially incorporates both the detection and capture technology. So the chip allows for
Okay.
really easy identification, capture, and cultivation of circulating tumor cells. And I think what's really interesting about that is the cultivation part. So what's now being able to be done is from these CTCs, which are circulating tumor cells, as I mentioned, you can cultivate it and track the growth of the cancer and predict its movement, so to speak, which really assists the medical team in getting ahead of it and treating and diagnosing it well before they would have been able to do before. And by tracking it, they can know where it's going to go, where it may spread, all sorts of amazing things which couldn't have been done prior to this chip. So it kind of works on the basis that it's hydrophilic. So for those of you that don't know, hydrophilic means it's water liking and thus draws molecules towards it. That's what kind of makes the capture process so simple. So the technology enables us to identify cells in the early stages of metastasis. And as mentioned, this is what allows for the early detection and treatment. Metastasis is the spread of the cancer to new areas of the body by way of the lymph system or bloodstream. Thus, a metastatic cancer is one which is spread from the primary site of origin or where it started into different areas of the body. So you can kind of see why this chip is so revolutionary in that previous liquid biopsies relied on EpCAM. So EpCAM is, I'm sure Viven knows this, but it's a protein situated on the surface of circulating tumor cells. And while that's good, the amount of EpCAM on a cell depletes throughout its life and as metastasis continues, meaning that the cancer becomes harder and harder to detect as it grows. Whereas what
Yeah.
we want is the exact inverse, isn't it? So it's not exactly ideal.
Kanishka, are there any potential issues with basically cellular isolation?
Yeah, so there are a couple of issues. One being that the red blood cells, which obviously are in blood and can constitute the main part of the blood, have a tendency, to settle at the base of the chip. And obviously, if something's settling at the base of the chip, you're preventing the CTCs, which is what we want, from successfully binding to it. And how the researchers have kind of circumvented this is by a process known as lysing, and that's where the red blood cells are broken up prior to processing, and this has led to amazing early stage test results. So we've seen a very high capture percentage of the CTCs. So what the researchers did was they spiked samples and put them onto the nanotube, and we've seen capture percentages of 89 to 100%, which is
That's
exceptional.
promising.
Yeah, it's very promising.
I think moving on from, well, in addition to nanotechnology, there's immunotherapy, right? So there's immunotherapy, which is, I think it's a treatment that helps your immune system work harder, or it makes it easier for it to find and get rid of cancer cells. So I remember reading how immunotherapy works in two ways, either stimulating or boosting the natural defenses of your immune system. So it works harder or smarter to find and attack the cancer cells. Or it can be made, it's about making substances in a lab that are just like immune system components and using them to help restore your immune system to find and again attack cancer cells.
Yeah, I think
But
one thing that is so hard about detecting the cancer cells is that they're not really that foreign. Like if you look at a virus or something like that, the immune system can identify them quite easily because they're extremely different from our own cells. But cancer cells are essentially just mutated human cells, which makes them so hard to detect, and that's why the immune system finds it difficult to identify and treat. I'd also like to mention that the reason this links kind of so heavily to nanotechnology is because of AAPCs, or artificial antigen presenting cells. And that's kind of what's enabling immunotherapy right now. So AAPCs are, as I mentioned, artificial antigen presenting cells, which need to interact with T cells in the immune system by binding to specific receptor points on the T cells, and then presenting them with antigens which initiate production of further killer T cells, which can then attack the tumor cells. So researchers have explored using a magnetic nanotechnology, and they've experimented with using blood plasma with these magnetic AAPCs, made as tumor-based antigens, so that they could react with the tumor, and was sent through the magnetic column. And the T cells, along with the AAPCs, which they were bound to, stuck to the magnetic column while all the other cells washed away. And the column's field activates the T cells, which were then able to be cultured and grown. And it was actually found that after a period of, I think it was a week, the cells had replicated by 5,000 to 10,000 times, which is obviously a huge step towards immunotherapy, and I thought it was worth mentioning.
exactly, that was exactly one of the limits. So the immune system can't differentiate essentially between normal cells and cancer cells. But it could also be the case that the immune system recognizes the cancer cells, but the response might not be strong enough to destroy the cancer. And I think that's where immunotherapy becomes a breakthrough, really, because with it, your cancer is less likely to return. So basically, when you have immunotherapy, your immune system learns to go after the cancer cells if they ever come back. So this is termed immunomemory, and it could help you stay cancer free for a longer time.
I mean, that's obviously very promising. If you're talking about almost a cancer vaccine in a way, that's something that could be exceptional, surely, right?
Yeah, I mean the process as well. I mean, just a brief intro into the process because it's quite heavy, but it's typically the patients receiving treatments every 2 or 3 weeks, and it consists of the patient receiving the medication via an intravenous drip for about 30 to 60 minutes. What's really good is that most patients report feeling better once they're taking the treatment on its first time. But naturally, there will be those side effects. But what's good about the side effects is that they're much less likely to impact patients undergoing immunotherapy than those being treated with chemotherapy.
Yeah. So I mean, what's I guess great about that is you're talking about could it potentially be given to people who don't have cancer yet and are trying to make sure they don't? So let's say people who are who have inherited a higher likelihood of getting cancer, could it be given to them to prevent them from getting it or not?
What I researched was that not necessarily be given through that sort of way, that immunotherapy can be combined with other treatments. So you see people going to all types of radiation therapy. So like approximately 50% actually of all cancer patients will receive a type of radiation therapy during their course of the illness. And the radiation therapy contributes to around 40% of curative treatment. But because immunotherapy can be combined with these other treatments, if the original process was entirely successful, they have a high survival rate. Scientists reported 3-year overall survival rate of 63% amongst 94 patients, I think, treated with this combination of drugs.
I think also on a separate kind of note, what's really bad about cancer is that um, I think you mentioned it's the second leading cause of death globally, but with the actual cancer drugs that are being used currently, being chemotherapy drugs, other things, only between 1% and 5% of those drugs are actually effective on the tumor, and with some articles actually saying less than that. And what nanotechnology is posing that's so promising is that it's enabled us to target delivery directly to the tumor. Um, so previous drugs would be circulating in the bloodstream, and some were filtered out by the nephron in the kidney, and that meant that very few actually got to the tumor. Whereas now, what we can do is kind of make the drugs larger in a way so that they're not filtered out, and equally have kind of specific binding sites and latch onto the tumor, so to speak, for more direct delivery. So nanoparticles also aim to improve absorption of drugs by the tumor, and they enable us to avoid healthy cells. So as I'm sure most of you will know, one of the huge side effects of chemotherapy is that it doesn't differentiate between cancer cells and human cells. It attacks every cell to get rid of the cancer. Whereas using nanotechnology and AI and everything involved with that, we can identify which are healthy and which are cancerous cells and avoid that completely, which is extremely promising because you're talking about far minimized side effects and just a far better process for a cancer patient.
With those
And
side effects, like you're saying, they are minimized by a lot. Obviously, you just have the general nausea, diarrhea, fatigue. But then there is that very small percentage. I think it was fewer than 5% of patients will experience much more serious side effects. So liver failure, activation of an autoimmune disease, or death even. But if you look at that percentage, that's so minuscule compared to chemotherapy.
yeah, it really is. One thing I do wonder though is ethically, how would utilitarians, Christians, Hindus respond to this idea of enhancing ourselves by using technology in our body? And of course, from a utilitarian perspective, they would argue that do whatever's best for the human race, and using nanotechnology is clearly what is best because you're talking about saving countless lives and preventing countless cancers. But I don't know if you have any view of what Hindus would say or anything like that.
Yeah, so personally, I'm Hindu. And after sort of going through the whole religion, just about its beliefs, Hindus call nanotechnology and essentially most advances in human biology technology as human enhancement. So the Hindu tradition approaches human enhancement as a potentially dangerous development, although for different reasons than Christian churches. Enhancement is troubling because it could be used to alleviate suffering, which is necessary to work off bad karma. So that's debt from bad deeds, intents committed during a person's past lives. So in this light, Hindus could see enhancement as keeping someone from cleansing themselves of these misdeeds from their past lives. So yeah, I think that's
I
from
mean,
a Hindu perspective, it's not the best idea.
from a Christian perspective, I think there's very little response till 2014, 2015 because there wasn't really much to go on because it's a really prevalent and new issue and kind of form of research, but it kind of highlights that gray area between science and religion. So a 2009 survey showed that I think it was 90% or at least 80 of the US population, which are of course mainly Christian, were against funding nanotechnology, which is quite astounding considering all the positives it could have.
True say.
But Christianity as a religion, me being a Christian, is not against improvement, of course, but fundamentalists will probably argue that we shouldn't meddle in God's good world because if God has designed the world to be this way, we as humans are made in the image of God, as it says in Genesis. So we could never compare to his greatness, and we could never edit his work any better. But I think from a utilitarian and atheist perspective, there's really no choice or no dilemma here. It's do what's best for the human race. Also, I touched on fundamentalist Christians. There are also parts in Isaiah which quote against modification of the human body or using anything in the human body, which is technology. And there's a quote which is that we should consider the work of God, for who can make that straight, which he hath made crooked. And I think that kind of highlights what I'm saying here. I think from a Christian perspective, fundamentalist Christians may disagree, but I think the key thing with any aspect of humanity is to do what's best for us and to progress as a race. I'm sure you'd agree.
Yeah, there's always going to be that clash between religion and science, where beliefs and facts, there's always going to be that intervention.
Yeah, I think there's no true way to avoid that. And I think that's a different topic for a different podcast, perhaps. But I think it's a really interesting point, the ethical aspect, because there's obviously that dilemma between doing what is clearly right and what would clearly benefit us the most, and then doing what would appease religious groups. And I know there have been certain religious responses with less orthodox religions saying, God would approve, so to speak, but more orthodox Christians and other religions saying that it's something that shouldn't be funded and an idea that shouldn't be entertained. But yeah.
Going on from, I guess, ethics, socioeconomics, its sustainability with nanotechnology and more specifically immunotherapy, you have to think about the patients and the families, because immunotherapy is very expensive. The families need socioeconomic support from providers and payers. There's all these private organizations that give out this help. So patients involved in clinical trials have stipends for transportation, lodging, and other living expenses covered as research study related expenses. When patients receive the immunotherapy outside the confines of a clinical trial, they need to finance their own living expenses or receive support from provider organizations.
Yeah.
Of course, there is that concern that as more patients pursue immunotherapy in the future, those resources will be increasingly stretched.
I think aside from that, I touched earlier on current liquid biopsies using EpCAM, and obviously most people know about chemotherapy. And liquid biopsies can cost anywhere between 5,000 and 10,000 US dollars, while chemotherapy can cost up to 30,000 Great British pounds, which is already an extortionate amount of money. So
that's so much.
I think the amount of money that is being used on this, if we do find ways to make nanotechnology cheaper and more sustainable and all of these things, it could have a huge impact on patient care and how many people choose to have chemotherapy and how many people choose to have that treatment, because I think it could become cheaper as we find ways to make it cheaper.
Exactly. Less so, hopefully, chemotherapy. Immunotherapy seems like the way forward.
Yeah.
I know immunotherapy, like I said, has so much taken into account, so many expenses. So I do understand the cost behind it, but there's always going to be that little change that we could make.
And I think, sorry to touch back on ethics, but there is also that side of, are you charging are you forcing someone to pay extortionate amounts of money for a disease that they had no control over? And that poses its own ethical implications, because surely that's somewhat unethical. But then you also have to factor in someone has to pay for the treatment, right? But that's a whole different discussion, as I said.
Could be a new podcast.
Just came up with an idea on the spot. So I think, closing up, nanotechnology is, as I said at the beginning, extremely, extremely promising. I think the amount of things that could be done with nanotechnology, whether it be just in cancer or in other fields of medicine, are mind blowing. Because if we do truly invest in research here, I think we could see a complete shift in the medical landscape over the next few years. I think liquid biopsies are extremely promising, and I think nanotechnology being used to deliver drugs via, those, I think I mentioned, like claw-like structures carrying the drugs, are, going to be revolutionary, because we're talking about seeing huge increases already. I think it does have its limitations at present. The use of nanotechnology in transference of drugs currently has only been proven to have an effectiveness rate of about 5%, which is obviously not as promising as we'd hope. But I guess it is slightly more promising than what we'd initially thought. And I think if more research is done and more funding is given to nanotechnology, we could see amazing improvements in the future.
I think that's it. Thank you for everyone listening. If you have any thoughts and ideas for maybe future podcasts, please put it down in the Google form in the description below. Subscribe and like the video, and please share it. Thank you for listening. We'll see you next week.